Hi everyone, welcome to my channel. We're gonna cover in this series of videos, we're gonna cover differential equations. The series will include all the material for a normal undergraduate class in differential equations. This material is taken from the Penn State University, and the reason why is because that's the material I have since I went to Penn State, but this should help any student in any college or any high school if they're taking somehow differential equation. Okay, let's start with this. So the first topic we're gonna cover with differential equation is classification of differential equations. So for differential equation, we should know that there are two kind of differential equations. There's one called ODEs. Okay, so one class is called ODEs and the other class is called PDEs. Okay, so the difference between ODEs and PDEs are the essential difference is the number of independent variables. So, so in ODEs we have differential equations where the main function that we're looking for depends only on one variable. So we can have a function that we're looking for like y that can depend on only one variable, either x or t. And it's usually it's usually obvious from the equation. Not always obvious, but we'll see in a problem what I mean. And PDEs are functions that depend on two or more independent variables. So we'll have functions like y that will depend on two variables, x and t, or we can have functions u that depends on x and y. So let's go through examples. So in example one, we see that we have y prime plus 3y equal 5. In this equation, we don't have it clear, but we can see that y prime it's a derivative, so it's a simple derivative, first derivative, and we can assume that this refers either to dy over dx, or we can assume that this is dy over dt. So we see that in the equation there's no more derivatives, that's the only derivative, so we can proceed saying that this is an ODE. The first one is an ODE. Okay. In the second one, we have the function u, but we can see the subscripts here. The subscripts tell us that u depends on two variables now. So we have for u function that depends on x and t, and y, sorry. So in this case, we see that my main function u depends on two variables, so therefore we have a PDE. So this is a PDE. Just one remark, usually PDEs have subscripts and they're expressed as this or this. So what it means is that the function u is the derivative is taken with respect to the variable x, and on the second part the derivative is with respect to y. So usually when you see this notation, they refer to PDEs. So in the third problem, we have a different kind of notation, but this one is a little bit clear because we have dy over dx. So here it's telling us that the derivative of y depends on the variable x. So we see that in example 3, the only variables that we have are y and x. And we see that the derivative depends on x, so we can say that y only depends on x, and therefore this is an ODE. On problem number 4, this is also a notation, a different kind of notation, but we see that this notation that we have like this refers to a partial derivative. So we see here that y has two kind of partial derivative. We see one that depends on x and one that depends on t. So we see that y depends on two variables, so therefore we know that this is a PDE. Okay, so I hope this is clear. It shouldn't be hard, except for the first problem where we can have, we can only have one variable here, and we cannot decide if this variable depends on t or depends on x. But usually when you see a y prime, usually that means that is dy dt. Okay, let's continue to the next topic. So the next topic is order of differential equations. So this is a very easy topic. So order of differential equation, you have to identify the order. And the order is just, the definition of the order is just the derivative with the variable with the highest derivative. So all we have to look is go and look for the variable that has the highest derivative. So in example 1, we see that we have y prime plus y equal 5t. So we look for the derivatives. So we have here the first derivative here. So we see that it's only one derivative. So we say that this is first order, because it's only one derivative. So in problem 2, we have y triple prime plus y prime equal et. So we see that we have first derivative here, and then we have third derivative here. So we can say that the highest order is 3, so this is a third order. In example 3, we have something that we have to be very careful. So we have a different notation here. So anytime we have a derivative with order greater than 3, we use this notation. So which refers that the derivative taken here is the fourth order. So we're taking 4 derivative, 1, 2, 3, 4, but we don't use this notation, we use the notation in parentheses. So we can see here that the derivative is fourth order, so this is fourth order. Just be careful because this problem has y to the fourth derivative plus y squared. Note that if we're talking about a power, this one has a power, but the notation is not between parentheses, so that doesn't refer to a derivative, it just refers to a power. So this is y squared, this is not y to the second derivative. So in this case, we have y to the fourth derivative plus y squared equals 0. So from here, we conclude that this is just fourth order. In problem number 4, we have y prime minus y triple prime plus t squared equal y. So we look for the variable with the highest derivative. So we see that is here. And we can say that this is third order. So third. In problem number 5, we have to look for the variable with the highest derivative. And we see it's here, so this is just a second order. Okay, one more time. The way you identify the order of a differential equation is just to look for the variable with the highest derivative. Okay, let's continue to the next topic. So the next topic is linear versus non-linear differential equations. So I have some problems here. So the first part here is just the definition of a linear differential equation. Just notice the structure of this linear differential equation and note that every variable with a derivative has a term next to it, called a n of t, which refers to a function. These functions a of t, note that they only depend on t. Also note that a function that depends on t can be also a constant. So we can have something like that. So basically, the definition of a linear differential equation is telling us that we cannot have another variable like y next to a y prime, or we cannot have a y next to a y triple prime. We can only have functions that depend on t or constants. So let's go for the first example here. Let me erase this. So in here we see that in the first example we have y double prime plus t squared y prime equal y. So we see that we have y double prime, this term that has a constant 1 next to it, so this one is fine. Y prime has a term t squared next to it, so based on the definition we know that we are allowed to have functions that depend only on t or only on x. So we're fine with this one, and y has a constant value next to it, so we can say this is linear. In the second example, we have y triple prime, we have a constant next to it, we have y double prime, but here we have a y. And remember the definition of linear, we can have functions that depend on the independent variable, so in this case t or x, but they cannot depend on y. So this problem here, because we have this y here, makes it non-linear. Also, another nonlinear term is here, because y squared is y times y. And if we look at the definition of linear differential equations, we see that next to a y, there's a function that depends on t or depends on x, but not on y. So, and what we have here is this y here, so this term makes it nonlinear as well. Okay, and go for the problem number 3. So here we have y prime plus sine of ty, y equal 5. So again, this term here next to the y has a y inside of sine. So this term here depends on the variable y, and we know that we cannot have a function that depends on y next to our main variable, in this case y. So this makes it nonlinear. Okay, so let's change it a little bit. So if we have y prime plus sine t of y equal 5, in this case we have y prime, so there's a constant next to it, a constant of 1, that's fine. There's this y here, and next to the y there's a sine of t. So this function depends on t only, so we're fine, this term is still linear, and the 5 is just a number, so we're fine here. So if we have this kind of equation, this one will be linear, because next to the y there's no function that depends on y, only a function that depends on t. Okay, so problem number 4. So in this case, this is a nonlinear also. And the reason why it's nonlinear is because it doesn't follow the definition of our linear differential equation, and we see that the derivatives should be in decreasing order, and we have the y here. Remember, the y, it's next to a function that depends on t. We don't have here any sine, any cosine, any tangent, any other function. We have y derivatives in decreasing order, and then we go down to a y variable, and next to the y variable we should have a function that depends on t. In problem number 4, what we have is y prime is next to a 1, so we're fine there, but then we don't have a y. We have sine of y. There's not a y, it's a sine of y, so it doesn't follow the structure of the definition of a linear differential equation, so this term makes it non-linear. And finally, problem 5, we have, well, this is the problem I already explained. So we have a constant term next to y prime. We have a function that depends on t next to the y. So the structure seems good. So we can say that this is just linear. Okay. One more problem I'm gonna give you guys is, so if I have sine of t y double prime plus y prime square plus y equals 0. Okay, so in this problem we have, I'm gonna open this problem a little bit. So we have sine of t y double prime plus y prime, because it's y prime squared, plus y equals 0. So in this case, let's look at the first term. So the first term has a function that depends on t and has the second derivative here. So we can see that this follows the structure of a linear, just the first term. So with the first term, we're fine. So far we can say it's linear. So let's go to the next term. So in the next term, we see the y prime. But next to the y prime, there's another y prime. So we know that we cannot have functions that depend on the same variable. So if we have a y prime here, we cannot have a function that depends on y. But we do have one here. So these terms makes it also nonlinear. Okay, and this term is fine and the 0 is fine. So we can conclude here that this is a nonlinear function. I mean a nonlinear differential equation. Okay, well, that's basically it for today. I hope this was clear enough and that you don't get confused between the difference between linear and nonlinear. You're able to determine what the order of a differential equation is and to differentiate or classify the differential equations into ODEs and PDEs. I hope you liked this video and found it useful. Leave a comment or a recommendation. I'll be posting more videos about differential equations, hopefully every day. And if you need me to solve a problem or cover certain topics, you can leave a comment or send me an email. I'll leave my email in the description, so you can send me an email and I will look at the problems or look at the suggestion and maybe do another video.